Hello friends. In this problem you have been given an exponential equation and you have to find the value of x that satisfies this equation. And the equation is you have 10 raised to the power x, 11 raised to the power x plus 12 raised to the power x, and this is equals to 13 raised to the power x plus 14 raised to the power x. So how will you find the value of x? Generally these kinds of problem has limited numbers of solution. It can have one solution or two solutions. So what we do is we find this solution by inspection and then we prove that this function has only one solution or two solutions, whatever. So let us use the same strategy to solve this problem. Let us check. So we will start with x equals to 1. So let us try whether x equals to 1 is a solution of this equation or not. So we will have 10 raised to the power 1 plus 11 raised to the power 1 plus 12 raised to the power 1. So this is how much? This is 33. So this is left hand side. So this is the value of left hand side. And what is the value of right hand side? You will have 13 raised to the power 1 plus 14 raised to the power 1. This is equals to 27. So left hand side is not equal to right hand side. So this means x equals to 1 is not a solution. Now let us check x equals to 2. So if we have x equals to 2, in this case you will have 10 raised to the power 2 plus 11 raised to the power 2 plus 12 raised to the power 2. So this is your left hand side. So 100 plus 121 plus 144. So this value is 365. Now what about right hand side? You will have 13 raised to the power 2 plus 14 raised to the power 2. So this means you will have 169 plus 196, which is also equals to 365. This means I can say that x equals to 2 is one solution of this equation. Now we have to prove that this equation has only one solution. So how we can do that? So let us divide this equation throughout by 12 raised to the power x. So what you have, this is your original equation. So let me write here. So this is 12 raised to the power x, 10 raised to the power x plus 11 raised to the power x plus 12 raised to the power x is equals to 13 raised to the power x plus 14 raised to the power x, and let us divide by 12 raised to the power x throughout. So what you will have? And you can use the rules of exponent, that is if you have a raised to the power m divided by b raised to the power m, this can be written as a by b raised to the power m. So with this rule I can write this is nothing but 10 by 12 raised to the power x plus 11 by 12 raised to the power x, and this is simply 1, and this side 13 by 12 raised to the power x plus 14 by 12 raised to the power x. So this is x. Now let us consider both sides. This side you have a function that's called, this is fx, and this side you have another function, that is right hand side. This is your gx. Now see, 10 by 12, this number is less than 1, and if you raise a power to this number, this will become even smaller. Similarly, this term, in this case again 11 by 12, this is less than 1, that is it lies between 0 to 1. So if you raise a power x, this will further be a smaller quantity. Now you can say this is a monotonically decreasing function, because as you increase x, the value of this increases, and the value of 1 you are simply adding to that function. So this side you can say this is a monotonically decreasing function. So this side you have a decreasing function. And what about this side? This side you have a number that is greater than 1, a number that is greater than 1. And if you raise power x, the number will increase. So as you increase x, gx will increase. This means this is an increasing function. So if you plot these two graphs, they are going to intersect at only one point. So if you see, let us say this is your x-axis and this is your, so this is your y-axis and this is your x-axis. So, and fx and gx both are positive. So this is monotonically decreasing function. So this is your fx. And what about gx? Gx is monotonically increasing function. So this is your gx. So this means they will intersect at only one point, and this point is corresponding to x equals to 2. If you are not convinced that fx is a decreasing function, we can also prove using calculus. So let us do this. So if I prove using calculus, so what is your fx? Your fx is equals to this function, that is 10 by 12 raised to the power x plus 11 by 12 raised to the power x plus 1. And what is gx? Let me first write f dash x. So I can find f dash x. And to find f dash x, that is derivative of fx, I will use one result. And that result is d by dx. This is from differentiation calculus. D by dx of a raised to the power x is equals to a raised to the power x ln a. So now I will use this result. So if I use this result, what I can say? I can write f dash x. This will be a, which is 10 by 12 raised to the power x, times ln a, and ln a is simply 10 by 12 plus 11 by 12 raised to the power x times ln a. Ln a is 11 by 12, and differentiation of 1 is 0. Now see, this both term is negative because this term is log of a number that is less than 1, and similarly log of a number that is less than 1. So this both quantity is negative, and this quantity is positive, raised to the power, again it is positive, and this is raised to the power x. So this is again a positive quantity. So you have a positive quantity and you have a negative quantity. Similarly here, positive and negative. So finally this is a negative quantity, this is less than 0. This means this is a decreasing function. So fx is a decreasing function. Similarly, I can solve for gx. So let us solve for gx, and if you remember, the gx was 13 by 12 raised to the power x plus 14 by 12 raised to the power x. So if you define or if you take differentiation, g dash x is equals to, use the same formula, 13 by 12 raised to the power x ln 13 by 12 plus 14 by 12 raised to the power x ln 14 by 12. Now see this number, 14 by 12 is a greater than 1. And if you take log, this will be positive. Similarly, this is a greater than 1. If you take log, this is positive. And this is positive. And this is also positive. So everything is positive here. So finally, this will be a positive. This means this is an increasing function. So this is an increasing function. So one is increasing, another is decreasing. So they will intersect only at one point. Now to further illustrate, I have plotted the graph of these two functions. So what was fx? Fx was this function, 10 raised to the power 10 by 12 raised to the power x, 11 by 12 raised to the power x plus 1. And if you plot, this is the function fx. You see, as you increase the x, this becomes very a small quantity and it becomes 0. But for negative x, this is a very large quantity. Because x is negative, then it will become numerator and denominator will be flipped and you will have a very large value. But overall, this is a monotonically decreasing function. Now let us consider the right hand side. So you have 13 by 12 raised to the power x plus 14 by 12 raised to the power x. This is your gx, that is the right hand side. And you can clearly see these two functions crosses at x equals to 2 and corresponding by value is 2.533 or 535. So this illustrates how you can solve this problem using inspection method and by adding the concept from calculus that this is one is monotonically increasing function, another is monotonically decreasing function. Another important point in this problem, that is I have divided by 12. If you remember, I divided both sides by 12. This is by 12, this is by 12, 12, 12. Now we have divided by 12. That's why we are getting one side monotonically decreasing and another side monotonically increasing function. So this left side is decreasing and right side is increasing function. But if you divide by 14, you will not get this kind of form, and it will be difficult to solve if you divide by 14. So you have to think by which value you should divide. I hope you enjoyed this video, and if you enjoy, please share with your friends, like this video and subscribe to my channel. Thanks for watching this video, and I will see with some more exciting videos in coming days. Thank you.